Katrina here, and today we're going to go over L'Hopital's rule and infinity examples. Be sure to subscribe for more videos like this and watch to the end. Okay, so I have some previous videos out about L'Hopital's rule, what it is, how it's derived, as well as other example videos. Today we're explicitly going to explore some cases when x approaches infinity and what happens to our functions and what happens to our limits. So we're going to dive into these examples and I'm going to show you how to use L'Hopital's rule to solve the problem. So our first example here is we have the limit as x approaches infinity of e to the power of x over x. So the first thing we always have to do is determine whether we need to use L'Hopital's rule or not. So the first thing we're going to do is we're going to check to see what happens to the function on our numerator and the function on our denominator as x approaches infinity. So f of x is our e to the power of x. So if we take the limit as x approaches infinity of f of x, we get e to the power of infinity. What happens there? Think about your plot over here. It means that your limit is going to approach positive infinity. If we now look at the limit as x approaches infinity of our denominator g of x, we get infinity. We get x equals to infinity. So that means it's also approaching infinity. So this means that we have some infinity over infinity case, and this is an indeterminate form. So that means that we have to use L'Hopital's rule. Okay, so L'Hopital's rule tells us that in this case, since we have an indeterminate form of infinity over infinity, then that means that the limit as x approaches infinity of f over g equals to the limit as x approaches infinity of f prime over g prime, provided g does not equal to 0. Provided g prime does not equal to 0. So now let's go ahead and then take the derivative of our f and g functions to see if we can solve this limit using this trick that we learned from L'Hopital's rule. Okay, so if f of x equals to, what do we have? E to the x, that means that f prime is also going to equal to e to the x, and then our g of x equals to x, so g prime equals to 1. Okay, so now we will go ahead and just evaluate our limit there. So let's see what we've got. We now have the limit as x approaches infinity of e to the x over 1, which equals to infinity over 1, which is just infinity. So that means that our limit tends towards positive infinity. So we went from having an indeterminate form of infinity over infinity to getting an answer that the limit approaches infinity, which is a valid answer for limits. Okay? Now we're going to look at another example, just so we can practice this a little bit. Again, please drop any comments if you have any questions and subscribe for more. Okay, so we've got now the limit as x approaches infinity of x over ln x. So again, let's test it out. We'll call this one our f of x, and this one here our g of x. So if we take the limit of the numerator, we have the limit as x approaches infinity of x, and well, this is approaching infinity. If we look at our denominator, we have the limit as x approaches infinity over ln x, and well, this also approaches infinity. So that means, again, we have another case where we have infinity over infinity, so that means we have to use L'Hopital's rule. So let's go ahead and then take the derivative of our numerator and denominator. So f prime of x equals to 1, and our g prime of x equals to 1 over x, because the derivative of ln x is 1 over x. So now let's go ahead and apply L'Hopital's rule. So we've got the limit as x approaches infinity of 1 over x. Okay, so we got a fraction over a fraction, what's happening here? Well, a little aside with algebra, if you have a over b divided by c over d, that's the same as a over b times d over c. So you can flip and take the reciprocal. So that means that in this case, we have the limit as x approaches infinity of 1 over x, which is just equals 2x. And then if we solve this, we plug in infinity to x, it tells us that our limit is going to be approaching infinity. So this is another case where we went from an indeterminate form of having infinity over infinity to just having our limit tend toward positive infinity, which again is a valid limit response or valid limit answer, and it's no longer trapped in an indeterminate form. So L'Hopital's rule allowed us to find the true value of the limit, allowed us to look past that indeterminate form. So be sure to always recognize cases when you can use L'Hopital's rule. Test the limit of your numerator and your denominator. If they both either equal 0 or if they both either equal plus or minus infinity, then you're on the right track to be using L'Hopital's rule. I hope you enjoyed this video. Please drop it a like and definitely subscribe for more. Hope you're having a wonderful day, and I look forward to seeing you next time.